Lesson 8.5, using the distributive property. Our essential question is, how do you use the distributive property to factor a polynomial? So the first property we have is distributive property. The second one is called the zero product property for our two new vocabularies. The distributive property, I'm sure you remember because we've worked with it a lot. What we're going to do with it in this chapter though is actually reverse it. So remember that the distributive property is used when you have something outside of the parentheses, and what we do is we distribute it or bomb it, multiply it times everything that's inside the parentheses. So A times the quantity B plus C means A times B plus A times C. So we multiply A times everything in the parentheses, or that would just be AB plus AC. The zero product property says that if two things are multiplied together and you get the answer 0, so the product means to multiply, so if the product is 0, so if A times B is equal to 0, then A or B must be 0. So think about that. If you know the answer to your multiplication problem is 0, then one of the things that you were multiplying had to be a 0, because anything times 0 equals 0. If A and B are both not 0, there's no way that your answer could be 0. So one of them or both of them has to be equal to 0 in order to get the product of 0. Okay. Use the distributive property to factor the polynomial. Remember what factoring means. Like the factors of 4 are 1 and 4 or 2 and 2. So 1 times 4 is 4 and 2 times 2 is 4. So the factors of 4 are 1, 2, and 4. So factoring. So what we are going to do is we are going to look for the greatest common factor, and we are going to take that out of our polynomial. So I'm going to move this over a little bit, and I just want to remind you that you could use a factor tree if you need to for factoring. 27 would factor into 9 times 3, and then 9 factors into 3 times 3. So the prime factorization of 27y squared, if you look at the bottom of your branches, I have 3 3's, so 3 times 3 times 3, and then y squared means y times y. So 27y squared, written as prime factorization, is 3 times 3 times 3 times y times y. I'm going to do the same thing with my 18y. 18 is 6 times 3, and 6 is 2 times 3. So the prime factorization for this one is 2 times 3 times 3 times y. So what I'm looking for is I'm looking for the greatest common factor. So I'm looking for what these terms have in common. I notice they have a 3 in common. Then they have another 3 in common, and they have a y in common. So 3 times 3 times y, or 9y, is their greatest common factor. Then what's left of each term, the first term there's a 3y plus, the second term there's just a 2. So that is how you factor 27y squared plus 18y. Their greatest common factor is 9y. If you divide each of them by 9y, you are left with 3y for the first term, and you are left with 2 from the second term. And then there was a plus in between the terms, so I kept the plus there. My next one is a trinomial. So with this trinomial, I have 5y to the third power plus 10y squared minus 25y. So I'm going to factor each one of these. 5 happens to be a prime number, so there's nothing I can do with it. So 5y to the third power would be 5 times y times y times y. 10y squared would be 2 times 5 times y times y. And negative 25y would be negative 1 times 25. And 25 is 5 times 5. So it would be negative 1 times 5 times 5 times y. Okay, so their greatest common factor, they all have a 5. They all have a y. And that's it. Because to be a common factor, it has to be common to all 3 terms. So the first 2 terms have another y, but the last one doesn't. Yeah, that's it. That's all we can do. Okay, so now 5y is my greatest common factor. And then what's left of each term? Y times y. It's y squared. 2 times y, so plus 2y. And negative 1 times 5, negative 5. That's how you factor. So I took out their greatest common factor, and then whatever was left of each term went in the parentheses. So we are reversing the distributive property here. Okay, now this one says use the distributive property to factor the polynomial, and it really is just like the last ones that we did. The only difference is you see more variables here, but that's okay. So I'll factor the first one, negative 1 times 4, and 4 is 2 times 2, so negative 1 times 2 times 2 times A times B. Negative 8, negative 1 times 8. 8 is 4 times 2, and 4 is 2 times 2. So if I bring this all down, here's what it looks like. And my last one, 2 is prime, so this is just 2 times A times B. Okay, what do they have in common? Well, I'm going to go all the way down to the end. This one's got a 2, so I looked for a 2 and everything. It's also got an A and a B, so an A and a B, an A and a B. Okay, so my final answer, I am taking out 2AB from each term. I'll move this down a little. Give me some room. So I have taken out a 2AB as their greatest common factor, and I'm going to be careful with what's left here in my parentheses because there are 3 terms. So the first one, negative 1 times 2 times A, would be negative 2A. The second one, negative 1 times 2 times 2 times B, would be negative 4B. The third one, here's what's tricky. A lot of times you think because you've taken everything out, you're done, but I need a 1 to hold that place. I need a 1 to hold that place. When we do a factor tree, we never use the number 1 because 1 is a factor of everything. But I could put that 1 in front right now because it would help me to realize that I need to save that space. If I take the 1 away, I wouldn't have 3 terms. I wouldn't have 3 terms. And remember, we're reversing the distributive property. So if you think about distributing here, you should end up with what we started with up at the top. So we need that 1 to multiply the 2AB by in order to keep this term. Okay, another one of these. Seven is prime, so 7x squared y squared. 21 would be 7 times 3, xy squared. and negative 1 xy, negative 1 times x times y. Common, what do they have in common? It looks like they've just got an x and a y. So I can take out that xy, and then what's left? 7xy, 21y, and negative 1. Here's my factored form. Now we're going to factor by grouping. Factoring by grouping, some students really like this method, and some maybe not so much. It's important to learn a lot of different ways to factor. So factoring by grouping, what we're going to do is we're going to group together two terms and then group together the other two terms. So I'm going to group together like this, and we're going to take out their greatest common factor. The greatest common factor of 4 and 8, without a factor tree now, would be 4. And then if I look at my variables, I can take out the y. So if I divide by 4y, my first term would be left with x, and my second term would be left with 2. Remember, you can always distribute to make sure that it's equivalent. Now, my second set of parentheses, 3x plus 6, they have a common factor of 3, and that's all. So if I divide by 3, I'm left with x, and 6 divided by 3 is 2. Now, look at what happened here. Our goal is for these binomials to match. Okay, if they do match, what we're going to do then is keep that x plus 2 binomial and look at what we factored out to get our second binomial. 4y plus 3. There you have it, factored form. So now think about how we know how to FOIL. We know how to FOIL everything to multiply our binomials together. We are reversing that process. We're teaching you how to take a polynomial and factor it down to its binomial factors. This can be a really important process when you're working in advanced math classes and science classes. Being able to factor will give you a lot of different options for solving quadratics. Okay, the next one, we're going to factor by grouping on this one. This one is pretty tricky though, because if I put some parentheses around this, looking at that next one, I can't just put parentheses around it because it's got a minus. And I want you to remember that this would not be equivalent. It would not be equivalent. So if I distributed that, look what happens. That's not what I started with, okay? So I've got to be really careful, and I'm going to try something out. If I take the negative out, I think I'm going to have to turn it into a positive. So distributing the negative, negative x minus 5, I'm correct. So I can have a negative there, but I'm going to have to change this into a plus in order for it to be equivalent. Okay, now taking out the greatest common factor. The greatest common factor in my first set of parentheses looks like they have a y in common. So if I divide out the y, I'm left with x plus 5. And good news, that's exactly what I was hoping for, because remember that I want those to match. I want these binomials to match. So they match. I'm going to keep it, my first binomial. Then my second binomial has to come from what I took out. So I've got a y, and then right here, I can put in a 1, so it's y minus 1. This one was a lot trickier than the first one that we looked at. So if you can keep a plus in between your terms, it's going to be a lot easier to work with when you factor by grouping. Okay, a couple more to try so that we can get some more practice on these. Group this one. Now remember, if I want to take the negative out, it's going to change the sign. So the negative was already on the 2y, but if I take the negative out front, I need a positive on my 7. Okay, the first set, it looks like all they have in common is an x. If I divide out the x, I have 2 and y left, and then 7. Perfect. Remember, I can put a 1 here. Multiplying by 1 doesn't change anything. So that looks good. So now my binomials match. So my first one is 2y plus 7, and then my second one is what was left out in front. So I have an x and minus 1. You can always FOIL to check and make sure that your answer is correct. You can always use FOIL. The last one. A little bit easier because we're back to having a plus between that second and third term. Okay, the first set I can divide 3 and a. 15a divided by 3a is 5, and if I divide by 3a, I'm left with a b here. Then my second set, I can divide them by 4, but if I divide them by 4, it isn't going to match my first, so I know that this needs to be a 5 minus b here in order to match. So I actually need to divide by negative 4. Because if I divide by negative 4, negative 20 divided by negative 4 is 5, and 4b divided by negative 4 is negative b. So now they match. So my binomial that matches is 5 minus b, and then the other one, 3a plus negative 4, or 3a minus 4. Factoring by grouping, when everything is positive, can be a lot easier. When you've got some negatives, that makes it tricky. Remember, though, that what is left, like when you're doing your factoring, your goal is to get those binomials to match. So you might have to manipulate your signs just a little bit, or the order of the terms, in order to get them to match. Okay, our last skill for the day, solve each equation using the zero product property. So remember, we said if a times b equals 0, then a or b must be equal to 0. So here's my a, here's my b. So one of them has to equal 0 in order for the answer, the product, to equal 0. So let's check it out. If this first one equals 0, I subtract 5 on each side, x equals negative 5. The second one, if that one happens to be the one that equals 0, I'd add 7, so x equals 7. So my answers are x equals negative 5 or x equals 7. It could be one or the other, or both. Okay, the next one. X minus 2 equals 0. Add 2. And x equals 2. Or 4x minus 1 equals 0. This one's going to take 2 steps. So add 1. 4x equals 1. And then I would divide by 4. So x equals 1/4. So x equals 2, or x equals 1/4. And then the last one, a is just 3x. So if 3x equals 0, and I divide by 3, x equals 0. So if there's a monomial out in front, that's going to mean x equals 0. My second one, x plus 2 equals 0, so x equals -2. So my two answers, x equals 0 or x equals -2. So that's using the zero product property. You should be able to write a summary now and then check with your teacher for your homework problems.